Yeah, hi. Great to be in Stockholm. Today, I want to talk about something that probably everybody of you uses, maybe not daily, but weekly, which is GitHub and GitHub Actions in specifically. And I want to talk a bit about how to attack GitHub Actions, insecure GitHub Action workflows, and I also want to show you how to defend against attacks. Yeah, boring slide first. Who am I? I'm Simon Gerst. I'm from Germany. I work as a security engineer at Asymmetric Research, where we are focusing on blockchain security. And I previously did my master's at KIT in Karlsruhe. So what are GitHub Actions? GitHub Actions are used for continuous integration and continuous deployment. You can use them to automate your workflows. They run on GitHub servers, so I'm not going to focus on self-hosted runners, but only on runners that are hosted on GitHub, and they are free for public repos. And why GitHub Actions? GitHub Actions are pretty easy to use. You can integrate them into the whole workflow on GitHub. You can make them react on issue comments. If somebody opens a new PR, pushes a commit, they are also easy to extend. You can just write some bash script or some JavaScript to extend it. And again, they are free for public repos, so I guess that's why they are so popular. And why do we want to attack GitHub Actions? They give access to the source code in many cases, and if you have access to your source code, you can do a supply chain attack. As I think just yesterday, the NPM packages have been attacked, or a few months ago, TJ Actions has also been attacked. And they give access to your secrets, so maybe AWS tokens, GitHub, Google Cloud tokens, so you can even escalate your privileges further. Yeah, the workflow files are written in YAML, have to be stored in a specific workflow, and they can be triggered by many different events, or you can trigger them manually, or you can also do like a cascade of where one workflow triggers a next workflow. Here's a very simple hello world workflow. You have to, or you can give a workflow a name. You have to specify when the workflow should be executed, in this case, when somebody pushes a new commit. Then you can specify multiple jobs which should be run. You can give, again, a name. You can specify the runner, for example, Ubuntu, Microsoft, or macOS, or custom runners. And then you can, for every job, you can define multiple steps. And in our case, we give this step hello world, and all it does is it greets the GitHub user which pushed the commit. And yeah, then we execute this shell command. As I already said, some common triggers are pushing to a branch, on push, on pull request. So you can do something build and pest, which checks every new commit you've pushed and every pull request you opened. It just checks out the codes, installs dependencies, builds the project, and then runs the tests. So pretty simple. You could also do some issue trigger. So maybe you're interested, if somebody opens a new issue, you maybe use Slack or Discord, or maybe you want to send an email, and then you can use, for example, a third-party action, which will then post a new message when somebody created a new issue comment. Or you can also use a cron job. For example, if you have issues on, you want to close stale issues. Or manually, workflow dispatch, which is a bit more involved. You can define custom inputs. You can define whether they are required, the type. So for example, if you have a workflow which builds the V8 JavaScript engine, you could go onto the GitHub UI, say trigger a new workflow, and then you can specify manually the version you want to build, and for example, the special build mode you want to use. And very important is to understand the permissions model for the workflows. Every workflow gets an API token, which can be used with the rest of the GitHub API, this GitHub token. And the base permissions for the token can either be set to permissive or restricted. And if it is permissive, the token has read permissions and write permissions to everything by default. Or if you set it to restricted, it only has read permissions. And if a pull request is from a fork, so from a repository that is different from the original one, the permissions are reduced to a maximum of read access. And you don't get any access to secrets. And there are a few triggers. Those few triggers, they give the base permissions and secret access. If you use the dangerous pull request target, it gives base permissions and secret access, even if the pull request is from a fork. And only pull request target is restricted for forks. And user-controlled input is always the root of all evil. And in GitHub Actions, you can use templating with the syntax, and the problem is that it is inserted as is into your workflow before execution. Inside the templating, you have some predefined variables, GitHub, so you can ask the GitHub object, what branch am I on, what is the commit hash, or you can look up in the environment or secrets. And you also get some predefined functions to work with strings, arrays, or JSON objects. And now we have, again, our example, which is triggered on issue command. And all it does is it prints the body of my issue command. And let's assume the body is just, this is a test. Then the string is inserted as is. And yeah, the string is printed, and if you're experienced, you maybe notice something, or if you're familiar with SQL injection or XSS, yeah, we are mixing code and data, which is always a bad idea, because if I change my command body to this, touch temp pound, it will execute code and create a new file in the temp directory. Because after templating, this string will look like this, and the shell will execute this sub shell and create the file, which shows that we just let someone execute arbitrary code, which is, of course, very bad. So how do we fix this? Don't mix code and data. Instead, store your data in an environment variable. So you just basically take this and put it here. So it is available in the env .comment. And then when the shell will execute the echo statement, it will not interpret the environment variable as code. And so you don't get any code injection, and no malicious stuff can happen. In some cases, you have to use this dangerous pull request target trigger. And this trigger gives access to secrets, and it gives access to a token with write permissions. So you could change the source code in the repository. And then an attacker can open a pull request against the repository. Some code that the attacker controls is cloned and executed. And yeah, again, we just let someone execute arbitrary code while giving them access to all our secrets and giving them a token with write access. In contrast, the on pull request is safe. Only pull request target is dangerous. And pull request is safe because it doesn't give access to secrets and write access to forks. So we have this example. We have our insecure pull request target trigger. And here we check out the code. And this SHA value is attacker controlled. So I check out some code from my attacker. Then I install dependencies and I build some stuff. And the problem is that I can plant a specific file that NPM will read when it's installing or building stuff. And in this file, I can inject my own commands that I, as an attacker, want to execute. So again, we are executing user-controlled code, which is bad. So how do we fix this? Easiest way is like don't clone and execute untrusted code. If you're familiar with binaries, there's this concept of an X-bit, no execute, or that you either make your code executable or writable, but never both. Because if you make your code executable and writable, you can get easily code execution by stacked buffer overflows or something like that. And if we take this analogy and bring it to the GitHub world, you should either clone and execute your untrusted code in an environment that is unprivileged, so something like pull request. And if you want to execute something in pull request target, you have to be sure that it is trusted code and not something untrusted you cloned from a malicious user. And sometimes this is not possible. Like you want to execute random pull requests, you want to maybe run coverage on the tests, and then you want to upload the coverage, or you want to write some command and post the results to the pull request or issue. And in that case, you cannot use an unprivileged environment because the unprivileged environment wouldn't have the permissions to post a comment on the pull request, for example. And in this case, what we can do, we can split the workflow to two parts. An unprivileged part, which clones and executes the untrusted user code. And then we can save the results as an artifact. And then we have our privileged workflow, which runs after the unprivileged workflow, that fetches the artifacts and then works with them. So this is our insecure example from before. We have pull request target, and we change this to just pull request because pull request doesn't give any write access. Then we execute our code, and let's just assume we upload some kind of artifact that we want to later use. What we then use is workflow run, which can be configured to run after a specific other workflow has run before. So we say if the workflow with the specific name has completed and it has succeeded, then run this job. And all this job then does is it adds a comment to the pull request which says the build was successful. Is everything secure now? Unfortunately, no. Workflow splitting also brings new problems. In this case, you want to save the pull request number as an artifact and reuse it later. So you upload, you use this, write it into the PR number file, then you upload it to the GitHub service, and then in your workflow run, you download the artifact, and you get the value of the PR number and echo it into the special GitHub environment variable. And that's also where the problem is, because we completely control the value of PR number. And this special GitHub environment variable, it works by having the key of your environment variable, the value, and it is separated by line fields. So if we can inject a new line into our PN number, we can also inject arbitrary environment variables into the GitHub environment. And for Node.js or for Bash or for many different programs, there's very often an environment variable where if you can control it, you can write some code which will then be executed. So you can, starting from here, you can poison the rest of the workflow. And you can again execute code. So how do we fix this one? There's pretty much only one really solution. You have to be like really careful when you work with untrusted data in your trusted workflow. You have to like verify that the types are correct, that your data is sanitized or that the data is escaped. Because, for example, in this case, we are uploading a number. And I guess everybody would agree a number shouldn't contain line fields, shouldn't contain alphanumeric strings. And that's actually something that's a bit disappointing that GitHub doesn't offer this natively. Like you cannot define outputs of a workflow that are then used as inputs of another workflow in a type-safe way. So like everything you get is like a string. And if you could define that you want this to output an integer, then this would be impossible, because an integer, as I said, can never contain a new line. And yeah, there are bonus problems with pull request target. So it's really something where you should be very confident of the implications if you use it. And pull request target, it uses the workflow file of the target branch. And like all other triggers, push, pull request, they always use the workflow file of your default branch. So your main branch always contains the definition of your workflow. But with pull request target, we are not limited to the default branch, to the main branch. We can just target any branch. So we can have different workflows for different branches. And what I've seen in the past is that the developer finds the bugs, fixes the bug, but he only fixes it on the default branch. And if you have a big open source project that has maybe hundreds or thousands of unused branches, and the chances are pretty high that some of those branches are still vulnerable, and yeah, you just pick another branch and you can exploit it again. And this is really a problem in practice. A good friend I know, he found some similar vulnerabilities in a popular open source project, and the vendor paid him like 30K for both. So it's impactful. Now, maybe your workflow actually doesn't have any permissions, it doesn't have any access to secrets, or maybe it only has permissions to post a comment, and you say, yeah, I don't care if some random person can impersonate me posting comments, because they can just post comments on the pull request themselves. It's not a big deal if they can do that. But with pull request target, this is not safe, because GitHub Actions provides a caching service. And in most cases, like with pull requests, they are not shared. But with pull request target, again, they are shared. So what you can do is you poison the cache, and then you hope that some more privileged workflow uses the cache, and so you can privilege escalate it. Okay, so how to keep safe fair? One important thing that many old organizations, like if you are an organization owner, you should look into this. And GitHub realized a while ago that the default of the permissive permissions is bad, like giving everyone a read and a write token by default is bad, so they changed it to only giving a read token. And the problem with reducing it to read by default is that then the workflow writer has to manually define which permissions it uses. For example, if it wants to write an issue comment, it has to declare that it wants to write 2 issue comments. And GitHub was afraid to change this default for all organizations and only did this for new organizations. So you should make sure that, if you want to harden your organization as much as possible, then you should make sure that it says read repository contents and package permissions, because this is the most restrictive. And even if your workflow successfully gets exploited, in the best case, it doesn't give the attacker much to do. But you then have to manually define what the workflow has to have access to. And another thing which you should make sure is unchecked is that GitHub Actions cannot create and approve pull requests. So if you have code owners or other rules defined in the GitHub UI that maybe 2 people have to approve your PR, then if you would take over the GitHub Action, the GitHub Action user could actually approve your pull request. You could approve the pull request yourself. Then you have 2 approvals. And then you can use the GitHub Actions user to simply merge your code. Something quite recently is you now have the ability to pin your actions to a specific version, or you can at least enforce this. Because if you just say, I want, for example, version 3 of a specific dependency, a malicious attacker who can take over the third-party action could simply publish a new version 3 that is then malicious, and your workflow will then start to execute malicious code. And if you pin this third-party action to a commit hash, you can be sure that it always executes the same action. But that's still not something that solves all problems, because even if you pin to a commit, you probably use something like Dependerbot or Renovate, which will then say, hey, there's a new version. You might want to update your commit to a new commit. And in the past, if you are unlucky, there have been new malicious releases, and then Dependerbot or Renovate would say, hey, there's a new update. Do you want to update to the malicious release? And so you still have to check what the tools are proposing to update. So if you just blindly apply every pull request that updates the commit hash, it's not that much safer than before. What is really nice is that CodeQL, which is GitHub's static analysis tool, recently added support for GitHub Actions, and it catches some of the most dangerous variants and also some lesser known variants. And it should be just flip a switch and it runs on a repository and it checks every of your commits for insecure workflows. And now I have some more resources, because there is a lot more than I could fit into this talk. There are the niche that works on self-hosted runners, so runners that are not hosted on GitHub. And even with hosted runners on GitHub, there are a lot more niche exploitation techniques. With that, thank you for your attention, and I'm happy to take any questions.
Right, do we have any questions in the room? Put up your hand. We'll get a microphone to you so everyone can hear. Oh, there we go, one.
You mentioned a scenario where, for instance, an attacker would impersonate comments as you, the author. Has there been any movement by GitHub to integrate actions with Copilot at all? So would there, if not, then this is not applicable, but if there was, then I could see a scenario where comments that are impersonated as you make their way into LLM input and then consequently, lead to LLM jailbreaks and doing stuff you don't want it to do. So has GitHub done any integration with Copilot and actions, or are they completely separate at this point still?
As far as I know, there is nothing in this direction.
There's another fellow at the back there who had his hand up.
Hi. So one of the other things that you kind of touched on was forking, and how people can probably fork a repository, clone a repository, fork it, and then create a pull request to the mother repo, for example. Has there been any more research into that, and how it opens up also a lot of other threats?
Sorry, I didn't get your question fully.
So you mentioned forking, like yes. How you can clone a repository, create a fork into the main one, and then maybe play around with executable code in a pull request. Is this something that you've looked into as well? You talked about executable code and changing pull requests in a fork.
I know that, for example, for Cradle wrapper, which is executable there, I'm not sure whether it's built into GitHub itself, but there is, I think, an action which verifies that the Cradle wrapper is authentic and signed.
Okay, we've got time for one more question, and whilst the microphone's making its way over, I'm old enough now, having watched Simon's talk, to realize that we haven't learned a fucking thing from about 1990, I'm going to date myself, 1997. Because I recognize the same class of really faulty thinking going on here. So it's quite depressing, actually. If anyone wants me after this, I'll be getting a very stiff drink.
Okay, you mentioned before that storing data in environment variables actually solves the problem. But does it, since you mentioned before that natively GitHub doesn't have the possibility of casting data, for instance, or use sort of parameterized queries like in SQL queries, isn't there the possibility of doing a second-order template injection? Here, for instance, in the comment body, you store the payload in the environment variables, and then it gets reflected into the run action.
Yeah, I mean, you still have to be careful. Like, this is safe, but if you then use the result somewhere unsafely, then you have the problem again. And what you really want to do is you want to avoid templating in any script execution.
Last question.
I have a follow-up question on this slide. Don't we get YAML injection? Because they do the templating first and then they interpret the entire workflow?
Sorry, what? YAML injection?
So if we inject a new line into the comment body and just keep on writing more YAML?
No, that doesn't work.
Why?
Why doesn't it work?
I mean, it's not literally injected into the workflow file, but it's injected into the, like all those run steps are basically a shell command, and so you inject into the shell command. But the workflow itself isn't executed on the GitHub runner.
Right. if anyone has any further questions, where can they find you after this talk, Simon?
Here.
Right here. There you go. You heard it from the man himself. Right. Thank you very much for making me feel at least very old and very depressed. Everyone, big round of applause for Simon.